Mapping and surveying professionals occasionally use the term datum, but what does it mean, and why are datums important? A datum is simply a standard reference point, set of points, or surface from which survey measurements are based. It's similar to the starting points you use when giving someone directions to your house, which usually include a point that they know, like a crossroads or a prominent building. For surveyors, that starting point is usually a nearby survey mark. When adjoining properties share these common starting points, it's easier to align them properly on a map. And when we all use a network of these marks spanning the continent, we share one national spatial reference system. For many decades, we have had two types of nationwide datums in the United States, horizontal and vertical, and they were generally separate from one another. Horizontal datums allow us to measure distances and directions across the surface of the Earth. Most horizontal datums define a zero line at the equator from which we measure north and south. There is also a zero line at the Greenwich meridian from which we measure east and west. Together, these lines provide a reference for latitude and longitude. Vertical datums are used to measure elevations and water depths. Sometimes the word height is used to refer to elevation information. Most vertical datums in North America use sea level as the basic reference plane from which we measure elevation changes. Because sea level varies along the coast for a variety of reasons, the idea of using multiple tide gauges to define the vertical datum was abandoned in 1988 in favor of using just one tide gauge. Now, thanks to the Global Positioning System, commonly known as GPS, and some other space-age techniques, we are no longer limited to separate horizontal and vertical datums. Today we have access to geometric datums, which combine latitude, longitude, height, and time information. The height information derived from GPS is relative to something called an ellipsoidal model of the Earth, instead of to sea level. While there are challenges mixing old and new positioning information, overall, new technologies like GPS help to improve the accuracy of our current datums. The North American datum of 1983, NAD 83, is the nation's horizontal or geometric datum. It provides latitude and longitude and some height information. The North American vertical datum of 1988, NAVD 88, is the nation's vertical datum, providing elevation information relative to a reference surface defined by mean sea level. U.S. territories have separate vertical datums. Unfortunately, NAD 83 and NAVD 88 aren't the only datums you will encounter. Before the current datums were defined, many maps were created using different starting points, and even today, people continue to change datums in an effort to make them more accurate. When combining data from different users or eras, it is important to transform all information to a common datum. Let's look at some examples of when and why using a consistent datum is important. Datums are commonly referenced on federal floodplain and topographic maps. Sometimes an older vertical datum for the United States is used rather than NAVD 88. In some areas of the country, especially in the West, differences between some vertical datums can be as much as 3 to 4 feet. This is pretty significant if you're trying to figure out if your house is in a floodplain. It's really important to know which datum your heights are referenced to. For any type of work where it's important for coordinates to be consistent with each other, it is critical that the same datum is used. If you are creating floodplain maps, marking property or land boundaries, designing levees or dams, building roads, or planning for coastal inundation scenarios, you must know about and use the correct datums.